Hello and welcome. In this video I want to show you some questions with limit laws. Before we start, let me remind you the limit laws. Limit of the function f of x plus g of x when x approaches a is equal to limit of f of x when x approaches a plus limit of g of x when x approaches a. But note that this law is true when the limit of f of x when x approaches a, this limit, and limit of g of x when x approaches a exist. So you can write this limit in this form as a two separate limit only when limit of f of x when x approaches a, limit of g of x when x approaches a exists. Both of them should exist. Otherwise, we don't have this law, and this law is not true. We cannot write this limit in this form. So the condition for this law is that limit of f of x and limit of g of x when x approaches a exist. Then we can write this limit as two separate limits. We have same law for subtraction. Limit of f of x minus g of x can be written as limit of f of x minus limit of g of x. And also for multiplication, also this is true. So if we have limit of f of x times by g of x, we can write it as limit of f of x as x approaches a times by limit of g of x as x approaches a. What about division? We have almost same rule for division. Limit of f of x over g of x when x approaches a can be written as limit of f of x when x approaches a over limit of g of x when x approaches a. But we have one extra condition, and that condition is that limit of g of x when x approaches a should be not equal to 0. So the limit of the denominator must be not 0. Then we can write this limit as limit of the top over limit of the bottom. And of course, like the previous laws, this limit should exist and this limit should exist, but the limit of the bottom should exist and not equal 0. So these are the important limit laws. One more limit laws that is not bad to mention is that limit of c times f of x. Let's say c is a constant like 2, 5, any number. Limit of c times f of x when x approaches a can be written as c times limit of f of x when x approaches a. So whenever we have a constant multiplied by a function, you can pull out the constant and put it here based on this law. Now that we reviewed the basic limit laws, let me show you some examples. Here we are given this information. We have a function f of x which we don't know what is the function, but there is a function f of x which when x approaches 5, the limit of that function is 12. We have this information. These are given in the question. Limit of g of x when x approaches 5 is negative 4, and limit of h of x when x approaches 5 is 0. And we are asked to find the following limits. The first question is this: limit of f of x plus g of x when x approaches 5 is what? Maybe you think, okay, the limit of this function is 12, limit of g of x is negative 4, and 12 plus negative 4 is 8. Yes, in that way you can find the answer. But you have to show your work if you just simply say this is 12, this is -4, and so the answer is 8, this is not a complete solution for this question. Based on the limit laws, we say we can write this as limit of f of x when x approaches 5 plus limit of g of x as x approaches 5. Now we can say limit of f of x when x approaches 5 is given 12. The limit of g of x when x approaches 5 is given -4. And so the limit is 8. The next question. What is limit of g of x all raised to the 2 when x approaches 5? Again, maybe you think, okay, limit of g of x is -4, so limit of g of x to the 2 is -4 to the 2 is 16. Yes, that's right. But it's better to write it this way. Note that g of x to the 2 is g of x times g of x. So it's a multiplication of g of x by itself. So we can write this limit as limit of g of x when x approaches 5 times by limit of g of x as x approaches 5. And because limit of g of x when x approaches 5 exists and is equal to -4, so this equals to -4 times -4 is 16. Again, it's not bad that I mentioned this. We can write a limit like this in this form only when we know that limit of g of x when x approaches 5 exists. Only when we know that each of these exists. Otherwise, it's not right to write it this way. The next question. What is limit of f of x times h of x over g of x? First, based on the division rule that we had in the limit laws, we can write this as limit of the numerator when x approaches 5 over limit of the denominator when x approaches 5. Now, based on the product rule for limits that we had, we can write limit of f times h as limit of f of x when x approaches 5 times limit of h of x as x approaches 5 all over limit of g of x when x approaches 5. What was limit of f of x when x approaches 5? 12. So this is 12. Limit of h of x, if you remember, was 0, and limit of g of x is -4. So this is -4. 12 times 0 in the numerator is 0. 0 over -4 is 0. So this limit is equal to 0. Next question. It's a bit unusual question. Limit x approaches 5 is square root of x2 plus f of x minus 1. First of all, we have this radical here. This is square root. We have a rule, we have a law for limits that limit of any radical with a function inside that, let's say that function, let me name it something like g of x, when x approaches a, can be written as radical limit of g of x when x approaches a. So we can move the limit inside the radical. Whenever we have a limit, we can move it inside the radical. But it's important that this limit of g of x when x approaches a, should be positive. Then, of course, you can move it to the inside of the radical. So based on this law, we can write this limit as the square root of limit x approaches 5 x2 plus f of x minus 1. You can write the limit in this form. And now, based on the limit laws that here we had, limit of f plus g is limit of f plus limit of g. We can separate the limit. So based on that law, we can write this limit as square root of limit x approaches 5 of x, attention, x2 is a function for itself, plus limit of f of x when x approaches 5. Finally, minus limit of 1 as a function. We can consider it as a function, or you can leave it as 1 and you don't need to write this limit, just simply you can write 1. But also you can say 1 is a function, it is a constant function, so we are going to write it as limit of 1 when x approaches 5. Now, what is the answer finally? Limit of x2 when x approaches 5 is simply 5 to the 2. We plug in 5 for x, so the square root of 5 to the 2. What was limit of f of x when x approaches 5? It was 12. So we have plus 12 minus, and limit of any constant, it doesn't matter x approaches what, is the same constant, is constant, so minus 1. 5 to the 2 is 25, plus 12, 37, minus 1, 36, so radical 36 or 6. So the answer of this limit is 6. Of course, instead of doing all of these calculations, simply you can say this is 25 here. Limit of f of x when x approaches 5 is 12, and you can get same answer. But always you have to show your work. Otherwise, your solution is not complete. I hope you enjoyed this video, and see you in the next videos.